Hello everybody, welcome to this series of workshops related to getting to know the PLCs that we have in the Schneider Electric offer. I'm your host Leandro Mada, and in this video what we're going to see is get to know the Modicon M172, which is this one, or at least one of those. Okay, so let's go to the presentation. So that thing that you can see going around over there is the image of the Modicon M172. Like this. Okay, you can see they have more colors, and we have different versions. Okay, but I'm going to explain just one of the features, okay, not the complete offer, okay, of this Modicon M172. For that, I'm going to create another video about the M172 offer. This is just to get to know the features that we have with this controller. So to do this a little bit more myself, okay, there's no need to go over there. Okay, so this is the M172, and you can see you have a square over there. This means that it's a display, and then we have a few things in the top, okay, in front. They are related to switches and LEDs. So if we continue with the presentation, here there is a zoom in. So we have on the left side, we have LEDs. Okay, there are 3 of these LEDs that we are able to program on the software. So we have yellow, red, and green. So we can program when we want this to be off, on, or blinking. On the right side of the controller, we have some switches that have indication up, down, left, and right, and OK. So we can make logic using this in the PLC software or for navigation on the display. Now, there is no need to have this display, so there is a blind version, and if you have the blind version, of course you don't have the embedded display and you don't have the buttons on the right side. Now, if we take a look here a little bit on the top, we should be able to have that mini USB here, so you can see on the screen. That will allow me to download the application on the controller or use the FTP in order to access to some files inside the controller. Then if we are using the Modicon M172 performance, we have performance unoptimized. You have a USB-B, so you can use a pen drive, and in the top part you have a Ethernet connection, Ethernet port, okay, they can also use for Modbus TCP or BACnet. And if you're using the optimized, as I have here, this part you don't have the USB-B and the Ethernet, okay, because it's not meant to do that, but you can have an expansion module. But just let's focus on some of the features. If you're using the one for the 172 performance, well, with Ethernet, you can access to the web server of the controller to make some modifications and have for example, your own designed website. Then if you take a look on the top, we have like 2 different layers, and it will depend on the amount of the IOs, but basically the in the top are related to the outputs, digital outputs. All of them are relay, and depending on the version that we are working with, we have different amounts of relays, okay. The power supply, which is something important, we have 24 volt or DC or AC. It's the same reference, so you can use the same PLC but different in case you want it. Something important is that this PLC I didn't mention is related to HVAC application, heating, ventilation, air conditioning. And the idea of this is because we have some kind of mix between digital inputs, digital and analog IOs, as you can see here on the screen. So basically we have a combination of analog inputs that can be configured, as you can see over here, okay. They can also be configured as a digital input. The amount will depend on the size of the controller and the version, but it's good to know that we have the possibility to configure, and we have already some embedded IOs inside this controller. Okay, for example, this controller, which is the 18 IOs, okay, it has the possibility to have 8 analog inputs, okay. So if you compare this with a traditional PLC that probably, for example, the M171 that has, depending on the version, it has 2 analog inputs to be voltage. Here you have vast range of analog inputs that can be configured. So if you compare that with, again, with the M171, in order to have, for example, temperature or current measurement for a sensor, you will probably need to add an expansion module here. You have just in one unit everything. Regarding the analog outputs, as you can see over here, we have, depending on the version, we have 2, 4, and 6, and always 2 of them can be configured as current, voltage, or PWM. Okay, the rest is going to be always 0 to 10 volts. One advantage of this controller is that also in the bottom, you can see in there, we have the possibility to use the a power supply. Okay, so this provide power supply energy to for sensors to 5 and 24 volts DC, which is good, so you don't need to use an external power supply. And on the bottom, again, the left side, you have the possibility to use communication. We have CAN bus and Modbus serial. The idea of the CAN bus is basically to connect to like a CAN master, so we can add expansion modules of this family M172 and allow me to connect them via CAN. And we also have the possibility to use something called CAN binding. So we have different M172 PLCs, and they can share data through the CAN using this CAN binding option. Okay, and we have 2 Modbus port RS485. It can be used for Modbus serial, or it can be used for BACnet. One of the ports can be only a slave, and the other one can be master or slave. So as you can see, we have communication already embedded in the controller. We have a good mix of inputs and outputs, digital and analog, and we also have the possibility to have an embedded display. And if you have one with Ethernet, we should be able to access remotely to see some of the variables directly. So the software to program this controller is a different EcoStruxure Machine Expert software. It is called EcoStruxure Machine Expert HVAC. One good thing is that it's free, okay, and it has 5 different languages. So we have structured text, function block diagram, ladder, we have instruction list, and sequential function chart, similar to GraphSet. Okay, so we have all those different languages available inside this this software, which is good. Again, for example, you compare with the M171, the M171 has only the GraphSet, and you have the instruction list and ladder. Here you have a bunch of languages. So said that, let's have some kind of demo workshop in here. The idea is to have the M172 use one of the analog inputs to read data from the temperature sensor that I have over there. It's a NTC. Then what I'm going to do is to show that information on the embedded display, and that information will be shown on the web server of the controller. Okay, so let's go to the software so we can get started with it. Okay, so here the first thing that we need to do is to define the controller that we're going to use. So I'm going to use this one, and I'm going to name this. So I'm going to be workshop M172 create. Just wait for this to finish. Let me resize this so you can see a few things. So the first thing that we need to do is to define the analog inputs that we're going to use. So here it's going to be analog input for temp room, and if I'm not wrong, it's already linked to the analog input 1. Okay, so this is the IO mapping that you can see. They have analog input, digital output, and the amount will depend on the controller selected. So I'm going to use that one. Here we have also the BIOS parameters. Now we should be able to configure all the analog inputs and outputs to know what it's going to be. So in my case here, these two are going to be NTC. By default are NTC, but it's good to define it in there. So we already have it already, everything configured. If you have, for example, the Modbus parameter can also be configured over here. So we have it standard, and here we have, for example, the IP address. In my case, I'm going to use 192.168.1.172, which is the one already connected to my network. It's not this one because this one doesn't have the Ethernet, but this one does. Default gateway 192.168.1.1. 255 is the network mask, and that's it. So I'm going to define here the configuration. In order to have cybersecurity, here we have the possibility to limit the access of the controller, and I'm going to use the default parameters in order to access remotely to the controller. Then you have a lot of things here, but that we can see that on my trainings, how we can get to know it. So the important thing is to configure the how is going to be our analog input and the IP address in this case. Then, for example, if you want to let's say that it's too hot on the room and you want to, for example, turn on the fan or the air conditioner, something to reduce the temperature. So we can create EEPROM variables that are, for example, configuration of the machine. So every time we turn it off and off, it doesn't lose the value. So for example, here I'm going to define a real value configuration, and I'm going to say, for example, temp set point is going to be real, and the default value is going to be, for example, 25 degrees. Okay, the minimum value is going to be 18 and the max is going to be 29. That is for scaling when you access. Okay, so I have this, the minimum values. Okay, fine. And then, for example, I'm going to use for indication our indication room temperature. This is what I'm going to share later, so don't worry. Great. So this is basically how we can configure everything. We have configured the analog input. We have created two variables, one to have some set points and the other one for indicate, which is the actual temperature in a different format. Okay, so we don't use directly the analog input. And then what I'm going to do is to use analog output just to indicate that, for example, cooling. Okay, so digital output cooling, just to indicate when the value reach more than what I want, it just turn on something. Okay, this is just to get familiar. Of course, there are different ways to doing it. So here in the library tree, we have different function blocks that we can use in our projects, and the idea of using this PLC as a HVAC is because we have some already predefined function blocks to be used in different applications. You can see air, energy measurement, electronic expansion valve. We also have that in the OFA. We have refrigeration and water. Then we have the PAVs, okay, pumping. So there is a lot of things that we can do here, but that will be covered later. The idea for you is to know that this controller is oriented for HVAC application. So it has a good mix of IOs. It has the possibility to have Ethernet, allow you to share data with other devices. Also, if you use Modbus, but we focus more into Ethernet. And then we have the specific libraries for this kind of market. So let's have a look here what we have. I'm going to save this project. Okay, I'm going to compile this just to know everything's fine. There is no errors at all. Good. Now what I'm going to do is to check where the variables are. Here you can see we have on EEPROM, we have the one that is going to configuration, analog input, digital output, and everything. So here, let's create a POU, which is a program organization unit. That is where our code is going to be called. Let's create a program, and here you can see we have different languages. Okay, so I'm going to use this FBD. So I'm going to use for subroutine inputs, just to read inputs, and then here I'm going to assign to the time task. So this one, what I'm going to do basically is to read the analog input that I have, and then what I'm going to do is to convert that to a real and divide it by 10, because when you read the value, for example, if the temperature is 18.5, okay, the PLC doesn't read that floating value, that real value, it just reads 185. So we have different ways to change that on the display to show the data, or we can change that to a real, so we can work on decimal points. Okay, so what we need to do just here is to drag and drop the variables into our code. So analog input here, good. Then if you go to basic conversions, sorry, here, conversions to real, okay, and then I'm going to divide it by 10, 10.0, and here arithmetic, I have the division. This space is a shortcut to make this, and then I'm going to assign the value that will lead to this indication temperature. Okay, easy. So now what we can do is to assign, for example, a different function block, new program. I'm going to use ladder in this case, SR output time. So you can see that we have different things. And then I'm going to add new program, structure text, SR control time. So you can see that we have different languages. You can see the full experience. Going to organize this a little bit, move down. So we read, execute the control, and then update the output as a normal PLC. So the control, what we need to do here is to make some kind of comparison to actuate the digital output. Okay, so let's create a global variable. Need cooling. So the idea of the control is to use this variable need cooling only when the temperature, the actual temperature, is higher than the one that I already configured as a set point. So if the actual temperature is higher or equal than the configure one, then else turn it off. Okay, we can do this in this way, for example. And This is one way to read it. Okay, this is one way to do it. So when the temperature is higher, just turn on this this indication that I need to be cooling off. So now that we have done the control, it's ordered to update the output. So here, what I need to do is to use the digital output. Here, cooling, and then here I'm going to indicate I need cooling. Okay, and what we can do is save this and add, for example, I need to save all this, okay, to add additional digital output, alarm, okay, in case the temperature is, the sensor is disconnected, we can do that. So, bottom, and here we need to use a comparison equal here and here, just to show you on ladder how it looks like. So if we disconnect 3, 5, 6, 7, 8, I don't remember if it is the number. When you disconnect the analog input, okay, it gives you a negative number. 3, 5, 6, 7, 8. If I'm not wrong, we can check it here. The commissioning. 3768. 768. Close enough. So we can compare with this number, and then it will give me the output for the alarm. Okay. Here you can add, for example, a comment. Alarm output. Write it on the other side. Alarm output. Coding. Okay. So I have all this. Now that we have already done this part, it's good to show the data on the HMI. So display pages here, and here we should be able to start creating the design that we want. I believe by default this is not in 1:1 scale on pixels, so I recommend you to change that, but that explain that on the training. So if we done the things right, we should be able to find on the HMI bars parameters all the values that we have from the PLC side. So here we just indication room, drag and drop, you're able to see over there, and here let's change the size, so it's going to be a dish much better. The format here is going to be a format decimal here, 1 integers 2. Okay, so this is showing. If it's showing, I'm going to use read only, and the border I usually put like this, so there is no feeling that someone can access and change data. And then the temperature, how we can program this, the set point, so it's going to be the same to 1, the same size. Okay, just to have the feeling that we have this part. And then we have the possibility to use the digital input or digital output. So for example, where is the variable that I have created? X, I believe it X something. Name. see, where is it? What was the name? Digital output, DOL, digital output. I don't remember the name, I have used it. DO cooling. Okay, the DO cooling was the digital output 1. Digital output 1. So we can drag and drop it over here. Okay. And the digital output 2, which is for the alarm. If you don't want to use, for example, 0 or 1, we can use text. So we have the possibility to use enumerative, rename, and on, off, on. 0, off, and on, cooling. And for example, here, alarms. Okay. Danger. Okay, so we can use that one. So here, that has a digital output 1. We should be able to use format. Here, enumerative on off. Don't worry about this, it will go off soon. The same can be applied for the alarms. Okay, now in order to show this a little bit much fancier, we can add on the page title. We can change the appearance, and here it's going to be workshop and 172. Okay, here digital output, no borders, and no borders again. So we can compile this over here, and everything should be fine. Okay, you can see this off and this one okay. Off. You can make this a little more fancier than I, but it's just to show you how it works. So I'm going to save this, and once I have everything already done, we should be able to connect to the controller to download this. So we just go to programming, online, setup communication. I'm going to use model TCP 192.168.1172. I need to check if I'm able to connect to it. CMD ping 192.168.1172. Okay, good. And then I'm going to download all. It will take a few moments. If everything goes well, it should be fine. You can see in the bottom I was connected, there was a different code not running. Now it's running the code. If you take a look here on the PLC, that is the PLC I'm trying to connect with. Okay, will take time. Yes, I want to download all the parameters except the Ethernet, so I can connect later. It's downloading everything. Okay, it must be rebooted. As you can see over there, I have the application, but then just need to reboot for the changes. Now it's rebooting, it's doing something over there. Just leave it in there, don't worry at all. It's loading the PLC, the communication, and the HMI, and you can see there in the screen the things. Okay, you can see there that I have the oops. Okay, you can see in there that I have the device. Sorry for the can, it's a little bit sensible. But I have on the right side the 25 let's wait for the display to go off. But you have the 25.0, which is the default the default settings that I have. I have the 21.4, which is the actual temperature in this room right now. If we, and the button you can see that is off, and then I have the indication over here, there is everything fine. So if I start pressing the sensor, variable on the left side should be raising the temperature in theory. Okay, 23, 24. Now should be changed 25.1. As you can see in the bottom, that is changed to cooling. Okay, the indication of cooling. And if we go to the code, we should be able to simulate this, not to simulate, to connect and see the actual status of the things. Okay, you can see it's needing cooling. Okay, this is fine. Now if I remove the analog, the analog segment should be able to turn this on. But you can see here in the input, the code, the control, how it's done. Okay, so let's try to remove the sensor, temperature sensor, and then you can see over there in the button how it changed. Okay, I don't have too much space here, so I'll try to do my best. Okay, you can see in there that I'm not okay, and here I use a different number. It's 32. Now let me just download this part again. Type in error. You can see it's in true, and you can see in the bottom right of the screen that I have the danger indication. Now if I manage to put this back again without blowing it up, you should be able to see that I have this in false and there is okay on the system. Okay, which is fine. Now this is how we can easily see and show the data on the display. Now let's take a look on the web server. Okay, so on the website, add table, new menu, site template. It's been a long time since I don't do this. So here, page title, it's going to be workshop M172. You can use password, but I'm going to do it. And here we can put the name of the variables that we want to use. In this case, it's going to be the temperature and the R indication, if I manage to get it. Indication, room temperature. The label is going to be temperature, set point, actual temperature. Okay, and then you can show the values over there. So in order to show this, rename workshop. What I'm going to do, we need to developer, build website. The website has done correctly, and here we should be able to have the download of the website. Website download on the commissioning. wait for it to finish. Brilliant. So now if everything goes well, we should be able to access to the IP address of the controller and access. So let's check it. So we can open the, I have open workshop, and then using the IP address, we should be able to access to this in this way. Okay. We can make some modifications. In order to change this, how it looks like, we should be able to change the enums indication on the controller. But for example, if I touch the probe here, you can see that I have 21.8, but in the website it shows 22. That is related to the how I configure the variable. Okay, but it can be changed. 23, but it's 22 dot something, 24. Okay, so you can add the variable. So it's just a drag and drop. So it's very easy to show data in this way. In order to change the way of visualization of the things, you need to configure the variables on this section. How it's going to be the format. Okay, 1 decimal. The status is going to be 1 decimal. So if we build website and I download again the website download, and then if the cookies allow me, I should be able to see the different way. Okay, you can see I have the decimal point. Okay, so just go back here on the presentation just in case I forgot about something. No, that's it. So the idea of this workshop is to show you some of the advantages that we have with the Modicon M172. That we have the possibility to use the display. We should be able to program it. We have some mix of input analog and digital on the controller. We can configure the analog inputs, okay, to be also digital in case we are using an application that is not entirely HVAC, but you need a few digital inputs. Of course, there are some limitations when you work toward this. For example, if you want to use the analog input, it needs to be configured in pairs. So if you use analog input 1 and analog input 2, they need to be the same type. You cannot have one digital and the other one NTC, but you can make the configuration. Later you should be able to see in the training all the different things that we have. But you have performance and optimize. If you have performance, you have the full access with Ethernet, the USB, and the micro SD card. Also, there was SD card, didn't mention on the presentation. If you use the optimize, you don't have the USB, the SD card, and the Ethernet option in the top. But the logic can be used for any of those, for optimize or performance. Then when you have the Ethernet or change the CPU, it's gonna be just fine. So you can use the same code. So this is for this workshop. So you get to know the M172 and also the software, which is free, and you have different languages on the controller. So thank you very much for watching this video, and I see you on the next one.